Hi and welcome back to part 5 of this Blender tutorial series on rigging a motorbike. In part 4 we set up our steering controls as well as our drift function. In part 5 we're going to be adding a bit of extra functionality to the steering and have that when we move our steering widget the entire bike rotates in this sort of arc like this. Tilting from left to right. We're only going to need a couple of bones for this, so let's jump into it and get started. We're going to go into edit mode and make sure that we're on the mechanical collection. We can turn off our controls for the moment. I'm just going to recenter our cursor and I'm just going to add a new bone and rotate this down and scale it down to 0.5. And this is going to be our mechanical tilt target. And this is the bone that's going to control, that's going to have a lot of the transformations on it, covering the steering mechanism that's going to rotate our bike in the y-axis, kind of rotating like this. There's a couple of extra bones we need. We're going to basically add 2 bones going up here and up here, doing the same thing as this front stretch. So let's add another bone here, cursor selected on the body, and we're going to snap this one from the tilt all the way to the body. And this is going to be mechanical body stretch, and we can do the same thing on the back wheel. Selection to cursor, and this is going to be mechanical suspension back stretch. We're going to take all 3 of these new bones and we're going to parent them to the drift so that our drift function still works. So we're going to parent all of those to the drift. And now we can start setting up our bone constraints. I'm just going to hide the axis for the moment just so we can see a little bit better what we're doing. So first of all, let's take our tilt target and we're going to add a transformation constraint to the mechanical steering. And we're going to map the rotational values in the Z-axis, so the same way that we did the handlebars, from the Z-axis to its local Y-axis. So it'd be this one. We can change these around, flip the axes, minus 90 to 90. So if I put my control collection back on and grab our widget, you can now see that as we move our steering, the tilt target is rotating around. Our body stretch, we're going to do a very similar thing that we did for this front stretch bone. We're going to stretch to the mechanical body. So now if I do this, nothing really moves. There we go. If I move my ground sensors, similar sort of thing happens. This stretches. Again, we can set this to none. And we're going to add another transformation constraint. And this time, we're actually going to be referencing from the tilt target. And what we're going to do is we're going to change these to, in fact, actually I needed to double check this. I left this in world space, I've just realised. This should be local with parent. And I mentioned in an earlier part of this tutorial that when we get to this part, there's a couple of specific examples where local with parent, or the difference between local with parent and local space becomes really apparent. So actually, let's set these to local space for the moment. It's not going to change anything just yet, but you'll see the issue that we'll run into in a little bit. So for our stretch, what we're going to do is we're going to target our tilt target, and we're going to change these again to local space. we're going to map the rotation, and this time we want to map the Y rotation of the tilt target, so minus 90 to 90, and we're going to map that back to the Z rotation. So we're going to flip these around, minus 90 to 90. Now, you may be wondering why this is even necessary. You know, we've taken the Z rotation of the mechanical steering and put it to the Y, and then we've taken the Y rotation of the tilt and put it back to the Z. We could have just copied the rotation of our mechanical steering, and yes, we can do that, but having this extra bone allows us to have an influence slider, which means that we can control all of the strength of our tilt by just turning up or down the influence of this one bone, rather than having to go through several bones. So now if we tilt this, that's actually working in the opposite direction. So we just need to flip this around, go from 90 to minus 90. There we go. Now when I tilt this, it's working fine. If I grab my ground sensor and move it up, and this is why, as I said, the order of these is important. We want to stretch first and then transform. If I did this the other way around, so we transform and then rotate, it's not going to work, because it's going to be stretching it afterwards. So we want to do it the other way around. We stretch first so that it gets to the right position, and then we rotate it around. We can do the same thing for the back tilt target, and there's actually a quick and easy way. If we've got the same constraints, we can just copy them over. If I select this bone and then shift select this bone, on this little drop down I can just do copy to selected, copy to selected. So now it's added those constraints directly onto this one, and the only thing we need to change is to get rid of this, and we're going to change this to the mechanical wheel back. This is all squashed down, and that's because the original length is copying the original length of this one, so this 0.74 value. If I just click X and close that off, it's going to reset it. So now we've got that working nicely, so that when we move our steering, these bones are tilting. And finally, to our front suspension, we're just going to copy over the transformation constraint as well, copy to selected. So now when I move our steering, this all moves. This has started moving. You know, we're getting some funky stuff going on with the suspension, as well as a bit of clipping through at the moment, and that's because our body and our wheels are not yet following. So let's set that up. We're going to do this on the deformation bones. So firstly, for the deformation body, we have this just at the moment parented to the mechanical body, because, as I said, in the first, I think it was in part 2, we set this up just to get some immediate visual feedback about what was happening on our rig. Well, now we can reset this. So let's delete the parent, and we're going to add a copy location constraint, and we are going to copy the stretch, the body stretch. Now it's obviously gone all the way to the bottom because it's following the head. Let's put it up to the top so it's following the tail. For the rotation, we're going to copy the rotation of the mechanical body, but only in the X and the Z axis. Our Y axis, so if I turn this off, our Y axis, we want this to be the same as our tilt target. So let's do another copy rotation. Let's copy the tilt target in the Y axis, and we want to set this to local space. So now when I turn this, if I go into a local view on the armature, you can maybe see a bit better what's happening. If I tilt this down, so what's happening is our steering bone over here is tracking towards our steering widget. Our tilt target is taking the Z rotation, so the, this rotation axis, and is transforming it onto the Y axis, so this way. Our stretch bone is then stretching to the mechanical body, which means that when we do our ground sensors, things are still going to go up and down. And then is transforming the Y rotation of this into the Z rotation of this bone. So now we can set up the exact same thing for the back wheel and the suspension, because at the moment we've got the body moving, but the back suspension and the back wheel are still being a bit funky. So for the back suspension, we're going to change the damp track from the wheel to the back stretch at the tail. So now it's following like this. Perfect. And for the back wheel, so we want the deformation wheel. Yep, there we go. We'd got this set so that we were copying the location of the back suspension and then copying the rotation of our back wheel. That's almost correct. We just need to do the same thing that we did for the body and separate out the Y-axis. So let's turn that off. Add another copy rotation constraint. That's going to be on our tilt target, on just the Y in local space. And now, let's turn off these collections, so I've just got my widgets. Our tilting works, which is great. Now, I mentioned that I think I set the tilt target to be in local space, because I want to show you the difference between local and local with parent. And that is that now, if I try to rotate my drift, our bike kind of gets a bit broken. It starts drifting around, and that's because this function, this is still, pointing towards, there's a discrepancy between the local space of this and the steering widget. If I change this to local with parent, suddenly it snaps back. And what that's doing is it's because it's now taking into consideration the parental hierarchy of this steering. This gets even more apparent in a moment when I show you this one other issue that this has now created. This is fine. This works. And this works. But what if I try and move my root bone? Oh, well, there's a couple of issues here in that my drift is not parented to my root. So let's do that. There we go. That works. But what if I try to rotate my root bone? That tilting takes into effect again. And this is because of that local with parent transformation. Because what's happening is now, if you look at our mechanical steering, this is rotated. Because it's taking into account all of the hierarchy from the steering all the way to the root bone. So when I rotate this tilt bone is taking into account the rotation of the parent bones as well. So we don't want that. So what we're going to do is we're going to add another transformation constraint just to basically negate this issue and to counteract that problem. So this one, we're going to take the root bone and we are going to map the rotations. We're going to do -90 to 90. And we're just going to flip it round. So 90 to -90 instead. So now when I do this, because I put it on the z-axis, which is not what I wanted. I wanted it on the y-axis, 90 to minus 90, and flip the source axes. And now when I rotate this, so this first transformation is doing our steering, and then that second transformation is just looking at the root bone and is counteracting the rotation. Now there is one other issue that comes up with doing this, with this setup. And this is a problem that we're also going to encounter when we come to set the wheel rotations as well. And it's called passing the U-turn test is what it's commonly referred to, or that I've seen it referred to. And that is that when we try to rotate this like this, it works absolutely fine. But what happens when we turn the bike around? Boop. It completely breaks. And that's because if we've set this to minus 90 to 90, but if we go further than this, if we set this range of motion even further to like minus 180 to 180, it's not going to know whether we're going this way or whether we mean that we're going this way. It's due to what's called quaternion rotation, and the mathematics of it is very, very complicated, and I'm not going to get into it. But basically the way that we're going to solve this is that if you're doing simple animation where your bike is just, maybe it's moving forward and it's like rotating around this way, and it's always going to be moving, forwards, then you can get away with just, animating this bone, and obviously the steering bones. If you're doing anything of a more complex movement where, you've, for instance, got your bike and you're going, like this sort of a route, to do that, you'd want to animate along a path. And that's going to be the final part of this tutorial series. So just delete those. And yeah, that is pretty much it for this part. We've set up our tilt target, added some more stretch bones, and reconfigured the way that the deformation, body, suspension, and wheel behaves. So now we've got a really nice tilt target. The final thing that actually we can add to this is it would be nice to add the function for the influence onto our controls here. So let's add a new custom property. And we're going to leave this as a float between 0 and 1. And we're going to call this tilt strength. Okay. And again, we can copy as a new driver, paste driver. So now we've got a tilt strength of 1, but I can then just scroll this back to control how much tilting we want on our bike. And yeah, that's it for this part. Join me in part 6, where we will be looking at the shock absorbers. So this part, and specifically rigging up the shock absorbers and this spring. So yeah, join me there, and I'll see you in the next part.